Stats 2023. This is Chapter 8, Section 1. This is the start of two-sample testing. This first section deals with sigma being known. A couple of concepts we need to make sure you understand is that two-sample testing, you have two different types. You have samples where there are independent samples, meaning one sample does not depend on another sample for its results, and vice versa. And then you have dependent samples, and specific examples of dependent samples are called pair samples or match samples. This is where we have a before or after, or we're comparing two different treatments to the same subject. Okay? So, independent samples, they have nothing to do with each other, but we're looking for a correlation between them. Dependent samples, a before and after comparison type of thing. The hypotheses for two samples test always deals with mu or p, and it's the same process as what we did before. If the null hypothesis is equal to, the alternative is not equal to. And it's based on the means for these first two sections. It's based on the means of the first sample versus the second sample. Let's resume we have the subscript 1. This means the mean of the first sample, the mean of the second sample. This is saying that they're equal. The alternative says they're not. If the null hypothesis says less than or equal to, then the alternative says greater than. If the null hypothesis says greater than or equal to, then the alternative is less than. It's the same three combinations that we've had before. They don't change. Okay? Also remember that same process. If p is less than the alpha that we're given, we reject the null hypothesis. If p is greater than the alpha, we fail to reject the null hypothesis. All right. So in two-sample testing, where sigma is known, one of the first things we've got to do is we've got to make sure that the samples are independent. If the samples aren't independent, we can't do this type of test. We have to do a dependent sample test, which we'll talk about later. We also want to make sure that the sample size of the first sample is greater than or equal to 30, and that the sample size of the second sample is greater than or equal to 30. That is our central limit theorem, unless, of course, the problem states that both samples are normally distributed. Okay, the sample we're going to do is example 2 on page 422. All right, so first of all, we have a chart here, or a little table, and it's the sample statistics for credit card debt. Notice in California, the X bar, the sample mean is 3,060. Sample size is 250. Notice the subscript 1 for the first sample mean and first sample size. In Florida, we have the mean average dollar amount is $2,910, and we have the sample size as 250. Notice the subscript 2. Problem says, a credit card watchdog group claims that there is a difference in the mean credit card debts of people in California and Florida. So the fact that there's a difference, they're not saying whether it's less than, greater than, or anything. They're just saying a difference. So that's the reason our null hypothesis tells us that California's mean is equal to Florida's mean. Mu1 is equal to mu2. Alternative says, no, they're not equal. Notice also that that's where our claim is, because that was the claim made in the problem. We read further, and it says the results of a random survey of 250 people from each state are shown at the left. That's the table that I just showed you. It says that the two samples are independent. So there's our independent. It's got to state that they're independent. Assume that sigma 1 for California is $960. Sigma 2 for Florida, $845. Says, do the results support the group's claim? So we're looking to reject the null hypothesis. If we do, that supports the claim. Notice that the alpha for this problem is 0.05, 5%. Okay? So again, I come back over here. Once we do this calculation, if P is less than alpha, we reject the null hypothesis, which means we can support the claim. If P is greater than alpha, we fail to reject the null hypothesis, which means we reject the claim. Okay, these two samples are purely calculator problems. All right, so what's going to happen here is I'm going to move over to test. If you look at number 3, it says 2-sample z-test. So that's what I want to do. I want to do a 2-sample z-test. So I'm coming down to number 3. I'm hitting enter. And you'll see I've already plugged the information in. Okay, make sure you're on stats, unless you get data. Notice that sigma 1 was 960. That was for California. Sigma 2 was 845. That was for Florida. Notice that mean 1 was 3,060. That was the mean average debt for California. Sample size was 250 for California. X bar 2 is 2009-10. That's the mean average credit card debt in Florida. Sample size is 250. Notice what happens. We have to continue to come down, and that's what the arrow out to the side says. Now, remember that these 3 right here are the the alternative hypothesis. All our alternative hypotheses are not equal to, so that's where we're going to press not equal to. We come down, we're going to hit calculate, and bingo, we got our p-value is 0.064. I'm going to round off. Okay. And our z is right there, which is 1.85. So if we look at this, we can see that with our p-value of 0.064, our p is greater than alpha, which tells us to fail to reject null hypothesis, which means we reject the claim. Now, when you do your problems for this particular test, I'm going to want to see the null and alternative hypothesis and what the claim is. I'm going to want to see what P is. I'm going to want to see the stats here, the X bars, the N's, the sigmas, the alpha. You don't have to do any kind of explanation to me. All you got to do is tell me whether you fail to reject the null or you do reject, whether you reject the claim or fail to reject the claim.